Uh, Hello everyone. Today we are presenting our project title Web-Based Visualizer for Structural Representation of C Programs. My teammates are Adil Malik, Abhishek KR, and Grishma RB. The contents are introduction, problem statement, project components, outputs, and conclusion. Programming languages are not processed as plain text before execution. The source code undergoes multiple stages of analysis to understand its structure and behavior. Our project is a web-based application that demonstrates this process by converting a C program into different structural representations such as tokens, abstract, syntax tree, control flow graph, CFG, data flow graph, DFG, and code property graph, CPG. These representations help students understand how compilers and AI coding assistants process source code internally. The project provides a visual and interactive way to learn important concepts related to program analysis. Now let's understand the problem statement behind this project. The next slide will be continued by Abhishek Kiar.
Myself, Abhishek here. My topic is on problem statement. Modern compilers and AI-powered coding assistants such as ChatGPT, GitHub, Copilot, Gemini, and Cloudy do not simply read programs as text. They analyze the structure, execution flow, dependencies within the code before generating outputs or suggestions. However, these internal processes are usually hidden from users, making it difficult for students to understand how source code is interpreted and analyzed. To address this challenge, we developed a web-based visualizer that transforms a C program into multiple structural representations. The system generates tokenization, AST, CFG, DFG, and CPG representations to demonstrate how source code is converted into meaningful computational models. This project helps bridge the gap between theoretical concepts and practical understanding of programming analysis. Next will be continued by Grishma RB.
Hello everyone, my name is Krishna and my topic is project components. Our project consists of five major components. The first component is tox, toxinization, also known as lexical analysis. In this phase, the toxin, toxinization, also known as lexical analysis. In this phase, the source code is broken into smaller units called tokens, such as keywords, identifier, operators, constants, and symbols. The second component is the abstract syntax tree or AST. It represents the hierarchical structure on the program and show how statement and expressions are organized. The third component is the control flow graph or CFG. It illustrates the sequence in which program statements are executed and show different execution paths. The fourth component is the data flow graph or DFG. It represents the movement of data between variables and identifiers, dependence among them. The final component is the code property graph or CPG. It consists of abstract syntax tree and control flow graph and data flow graph into a unified representation, providing a complete understanding of the program. These concepts are widely used in compiler design, static code analysis, software testing, and modern AI coding assistants. Now let us look at the output generated by our application, and the output is continued by the Adil Malik.
Hello everyone, myself Adil Malik. I will be explaining about the output and the conclusion part. This is what you are saying is the structure and lexical analyzer platform for our C program. Here we have to input any C program code. Here we can see all the tokens. We have tokens, keys, identifiers, and operators. These are all the tokens we have got. This is the AST. We have got a total complete diagram, and CFG we have got all the step by step diagram. This is DFG. This is complete diagram we have got, and this is the CPG complete diagram. This is the complete code we have done, and by analyze program, we can get all the inputs and outputs through this. It completes the source code and the conclusion of these things. This structure visualizes. It has all the outputs. The first output is the tokenization results, which displays all the token identifiers during lexical analyzing. Finally, the application generates a code property graph which combines information from AST, CFG, and DFG to provide a complete representation of the program. Stop, Abhishek.
Mm.
Uh, in conclusion, this project demonstrates how a C program can be analyzed and represented using tokens, abstract syntax tree, control flow graph, data flow graph, and code property graph. These representations help us understand program structure, execution flow, and data dependency more efficiently. The project also highlights the connections between automata theory, compiler designs, and artificial intelligence. By visualizing these concepts, students can gain a deeper understanding of how programming languages are proceeded and how modern AI coding assist work instantly. Thank you, everyone.